let's dive into something we all see every single day, but maybe don't really understand: color. Because as we're about to find out, what you think you're seeing, well, it isn't exactly what's out there.
Okay, let's just start with a really simple question. Take a look at this apple. It's red, right? We can all agree on that? But what if I told you that the redness you see, it isn't actually a property of the apple?
Here's the truth. Color doesn't physically exist out there in the world. It's a sensation, an experience that happens completely inside your head. And this is the key takeaway, really. Without you, the observer, there's just no such thing as color.
So to really get how this works, we need to look at the three essential ingredients that have to come together to make color happen. You need a light source, you need a surface for that light to hit, and you need an observer. Yep, that's you, to process it all.
All right, so let's tackle ingredient number 1. This is the foundation for absolutely everything we see: light itself. This is the physical reality that starts this whole incredible process.
So what is light? At its most basic, it's just a form of energy that travels from a source, like the sun or a lamp. If you're in a pitch-black room, there's no light energy, so no color can exist. It's the absolute starting point. No light, no color. It's that simple.
Okay, now this is where it gets really cool. Light has this kind of weird dual nature. On the one hand, as you can see, it travels in waves. And the length of those waves is what our brains eventually translate into a hue, red or green or blue. But at the same time, light also acts like a stream of tiny particles called photons. And the number of those photons hitting your eye determines how bright or intense that color is. So you've got the waves giving you the color and the particles giving you the brightness.
So we've got our light source shooting out all these waves and particles, but light just flying through space isn't enough. For the next part of the story, we need our second ingredient: the surface that light actually interacts with.
So things in our world have what are called colorants, pigments, dyes, that kind of thing. But here's the twist. These colorants are not actually colored themselves. A better way to think of them is like tiny, picky sponges for light. They're built to soak up certain wavelengths of light and to let other wavelengths just bounce right off.
Right, let's go back to our apple. When regular white light, which actually contains all the colors of the rainbow, hits that apple, the colorant in its skin gets to work. It starts soaking up all the energy from the orange, the yellow, the green, the blue, and the violet wavelengths. The only wavelength it doesn't absorb is red. That red wavelength gets reflected, it bounces off the apple, and that's the light that then travels toward our eyes.
And here's where it all clicks. Imagine you take that same red apple and put it under a pure green light. What color is it now? Well, the green light has no red wavelengths in it, so the apple's skin absorbs that green light, but there's nothing left to bounce off. And so, the apple appears black. The color was never in the apple to begin with. It was always in the light. Okay, so we've got light flying from a source, and we've got a surface that reflects just a certain part of that light. But at this point, that reflected light is still just energy. It doesn't become color until the final step. And that brings us to ingredient number 3, which is, without a doubt, the most important part of this whole equation: you.
So that red wavelength that bounced off the apple, it enters your eye and it hits the retina in the back. Now, your retina is just packed with millions of tiny light-sensitive cells, and their job is to be translators. They take that light energy and they convert it into electrical signals. Those signals get sent up to your brain. And here's the magic trick. Your brain isn't a passive receiver. It actively constructs your visual reality. It builds the image and creates the sensation that you experience as the color red.
And your retina has 2 main types of cells doing all this work. You've got rods, which are awesome in low light. They're great at seeing contrast, like black versus white, and spotting movement. Then you have the cones. They're the color specialists, but they need a lot of light to do their job. And this explains why when you walk into a dim room, you can see shapes and outlines, but you can't really make out any colors. Your cones have pretty much checked out for the night.
And this really brings us to the main point of all this. The physical reality of light, its measurable wavelengths. That stuff is fixed, it's objective. But our visual experience of that reality, it's completely variable. It's perceptual, and it is totally subjective. It all depends on the light, the object, and the unique way your own brain is wired.
So, why does any of this matter outside of a science lab? Well, for anyone who's a designer, understanding this gap between reality and perception, it's literally everything. It's how our world gets built. You see, a really good designer knows they aren't just picking out a pretty blue,
They are actively manipulating the physics of light and the psychology of our brains to guide how we feel, what we pay attention to, and even how we behave. You could almost call it perceptual engineering.
And once you see it everywhere. Look at the color-coded files on the left. That's not about looking pretty, it's about instant identification in a huge system. Or on the right, that specific shade of orange on a warning sign is chosen because it screams for our attention against most backgrounds, alerting us to danger. It's all about controlling our perception to achieve a goal.
Interior designers are masters of this. They use these exact principles to create illusions all the time. Painting a tiny room a bright, cool color can make it feel way more open and spacious, and painting one wall a warm, dark color can make it feel closer, more cozy and intimate. They are literally designing the feeling of a space, not just what it physically is.
So the next time you look at a red apple or a blue sky, just remember, that color isn't really out there in the world. It's its incredibly complex and beautiful story being told inside your own mind, a story that's co-written by light, a surface, and you. And it really brings this quote to life. We don't see things as they are, we see them as we are.